Hello my dear students, I welcome you to NEET World. So this is our third session on chemical kinetics right now. So we have discussed about order, molecularity and how can we write rate expressions and rate laws for a given particular reaction, and we also discussed the zero order reaction. So how can we calculate the differential equation and integral equation of zero order zero order reaction, we discussed in the last class right now. So now in continuation to that, so I will be discussing the differential equation and integral equation for first order equation, and also we will solve some questions related to this first order equation from NEET and JEE exams. Okay, yes. So just tell me everything is clear now. Yeah, so let's begin the session with first order equation. See, and also how can we calculate units of rate constant. For example, here I am showing you what is the units of this third order reaction. So what is the simple formula I have given to you? So in the last class, if you haven't watched the last sessions, just watch them, and if you are new to this channel, please click on the subscribe button so that you will get daily updates from us. Okay, yes. Yeah, so look at here, I have a question I have a discussion on this first order reaction now. See, I have a reaction like A. So A is a reactant forming some products P. Okay, this is what product is formed from this reactant A. Okay, so rate law for this first order reaction, I am discussing about first order equation or first order reactions here, first order reactions. Okay, so now rate of this first order reaction, rate of reaction is equals to or directly proportional to concentration of A. Okay, and first order I am saying now, so whatever here you need to represent here, M represents order of that reaction. Order of a reaction is given from experimental observation, not theoretically, it's an experimental data. Okay, so since we are discussing about first order, it's the value will become 1. Okay, so now rate is equals to, I am removing this proportionality, replacing a K, rate constant, product of concentration, like this. Okay, so since we are talking about first order, I am writing it as K1. Hope this is clear how to write rate law for this. And now how can you write rate expression for this? See, rate means change in concentration of A with time now. So for example, if this reaction is taking place, okay, so see here, if the reaction is initially at time 0, I have concentration of A as small a, and we do not have any product now, concentration of product is 0 at the beginning of the reaction. After some time t, concentration of A decreases by some quantity, let us say the decreased quantity is X, so that amount of X is converted into product formation, like A minus X is the decrease in concentration of A, or amount of A remaining after time t. See, after time t, X is the amount of product formed, A minus X is the remaining concentration of A. Okay, now rate of reaction is written as concentration of A decreases now, see it is decreasing as time goes on. So with change in time dt, change in time, there will be decrease in concentration of A, that is decrease means negative, change in concentration of A minus dA by dt represents rate of this particular reaction with respect to reactant. This is how you need to write. Okay, so now I am writing this, rate is nothing but minus dA by dt I am writing. Okay, yes, this is equals to K1 into concentration of A. We can write like this now, yes. Okay, now try to, this is a differential equation I can say. Now just apply integration on both sides. So what you are going to get on integration of these, so dA, see here I just wanted to convert, see here dA is there now, so I just wanted to bring this A towards this side, so that what happens to this equation, minus 1 by A dA is equals to K1 dt. I am applying integration now, K1 is a constant, so dt, like this. Okay, so at the beginning of the reaction, time is 0, at time 0 concentration of reactant is A. After some time t, concentration of reactant becomes A minus X. Right now apply upper limit and lower limits. Okay, then next, so upon solving this, what is the integral of 1 by x dx? 1 by x dx is ln x. Okay, ln x. Similar to this, here we will get 1 by a dA means ln a. Okay, and what about upper and lower limit? A and a minus x. Negative size as it is. Okay, here k1 dt means differentiation or integration can be removed. So we have t 0 and t, lower and upper limit. Okay, so now here just substitute this upper limit minus lower limit, you will get minus of ln a minus x minus ln a, upper limit minus lower limit means it will be like this, and this will be k1 into t minus 0, it will be k1 into t. Okay, hope this is clear up to here. So apply negative sign into what, into this. So what happens? ln a minus of ln a minus x. Okay, this is equals to k1 t. Okay, so this is log a minus log b form now. So you can write log or ln of a by b equals to ln a minus ln b. So this is like ln a minus ln b. So I can write ln a by b. So ln of a by b, a minus or a by a minus x is equals to k1 t, equals to k1 t. Like this you can write. Now what about t here? So t is equals to 1 by k into ln of a by a minus x. Okay, you can write this equation in terms of log also. So t equals to, so instead of writing ln, you can write 2.303 log. Okay, so use this relation here so that you will get 1 by k, ln place I am writing 2.303, so it becomes 2.303 log a by a minus x. Like this also, right? You can write, see, a is the initial concentration, sometimes it is also indicated as a naught or c naught. Okay, so a minus x is the concentration at time t now for the reactant, so that is indicated as at. Okay, so this equation either you can write like this, sometimes it is also indicated in this manner, t equals to 2.303 by k log what I can write, a naught by at. So why I am writing like this? Sometimes for graphical representation they won't use this term, they will use some other terms like a naught and at. So just to give one graphical like graph from this, I am taking this a naught and at. Okay, so just look at here, I can write this as k1t, just multiply here this k1. Okay, k1t by 2.303 equals to log a naught by at. Log a by b formula is what? Log a minus log b. No? So apply here log a naught minus log at. Right now we will get like this. Okay, so at means what? See, I just want concentration of a at time t this side. So we will get log at is equals to log a naught. Okay, log a naught minus k1 by 2.303 t. Okay, like this you should write. Okay, so just look at this, it is in the form of y equals to mx plus c graph. So log at is equals to minus k1 by 2.303 into t plus log a naught. Right now this is how it is. So y equals to m and this is t is x and plus c. Okay, so we have our negative slope and positive intercept right now. So how can you represent this? Log at on y axis and this x is what now? Time. So time on x axis. Like this you can take. So what about our slope? This is in negative terms and intercept is positive. So positive intercept, negative slope, like this. Okay, so this is intercept log a naught. Okay, so this is a log a naught value. Okay, and what about our slope here? Slope m is equals to minus k1 by 2.303. Okay, they will ask like this, what is the slope for this equation? This is the slope for first order equation. Hope this is clear. Yeah. So now what are the other things you can expect from this first order equation? See, what is the final outcome we got? So t equals to 1 by k into 2.303 log A by A minus X you got now. So now what is the time required for half of the reaction to complete? It means I have 100% reaction 100. So half of the reaction means concentration of reactant is 100. In order to bring it to 50, so we required T half. It means time required for half of the reaction to complete. So this is T half. Again this 50 becoming 25. Again this is one more T half now. Yes. So this is for time required for 75% completion. So I can say T 75% equals to 2 T halves. Okay, like this. You have to relate it like this for first order reaction. Now what is the exact formula if I want to bring for first order reaction for T half? So T half of this first order reaction equals to 2.303 by K log, what is the initial concentration for our assumption? I am taking 100. Okay, A minus X, time required for half of the reaction completion now. It means out of 100, 50% is completed, 50% is remaining. So A minus X is what now? It is 50. So this will be 100 by 50 means 2. So log 2 will be how much? 2.303 K log 2 is 0.3. So how much you are going to get here? So you will be getting 0.69. Okay, 0.69. 69 you can take into by K, this is what? T half. Okay, this is what the formula you should remember. Okay, so T half of a first order reaction is 0.69 by K. Okay, they may ask for K, rate constant, or they may ask for T half. Very, very important. Okay, hope this is clear. Yes. So let me move forward. See, what are the examples? Now you might have doubts like, what are the examples of zero order reaction? So decomposition reactions. Okay, and yesterday we have discussed, last class we have discussed about acid hydrolysis of esters. Okay, and here next what I can say, all radioactive reactions here, radioactive reactions, just simply take radioactive reactions are examples of first order reactions. Okay, write this. Okay, next we need to do some questions, numericals related to first order reaction now. Okay, so let us discuss few numericals related to this. So look at here. The first order, see this JEE Main 2023 question. Question says the first order reaction A to B, the half life is given as 30 minutes. It is 30 minutes. Okay, so T half is given as 30 minutes. Okay, the time taken for T 75% completion. See, just now I have given in the last slide. See, if 100% concentration of A is there, so for time required for 50%, I can say 1 T half. Again 50 becoming 25 means this is again half now. This is also again one more T half. So from 100 to 25, this is nothing but T 75% completion now. They are also asking for 75% completion. So T 75% completion is equals to how many T halves? Here one, here one. So you just take 2 T halves, that's it. Very simple now. So 2 into 30. So how much time you require? 60 minutes are required for completion. Okay, so you should answer here as your 60 as your answer. Hope this is clear. Right. Okay, so now one more question I just wanted to give you. Look at here, an organic compound undergoes first order decomposition. If the time taken for 60% completion, 60% decomposition is 540 seconds, then the time required for 90% decomposition. Very simple. See what is the equation we should take? K equals to or T equals to 1 by K and 2.303 log A by A minus X, right now. So what they are saying, T 60%. Okay, T 60% equals 2.303 by K. So how much concentration is remaining? See, A is converting into product. Okay, they are saying 60% completed. Out of this 100%, 60% is completed. It means remaining will be 40 only now. So this side is 60. If this is a minus x will be how much? 100 minus 60. So you should take here it as 40. Okay, 60% is done. Remaining a minus x, concentration of reactant is 40 only. That is what you need to understand from this 60% means. So log here a is 100, a minus x is how much? 60. Take it 60 here. 6, not 40 here. How much here? 40 here. A minus x is 40. So this is 10 by 4 we have. Okay. So now one more they are saying, then time required for 90%. So T 90% is equals to 2.303 by k log 90% means 90% is over, 100 minus 90, so 10% only remaining. So initial concentration is 100, remaining concentration is 10. That's it. So I can remove these two things. Log 10 will get 1 here. See, I am taking the ratio of these two things. These two are constants now. Remove that. Okay. So time required for 60% is given in the question as 540 seconds. By we require to find for T90 right now. So this is equals to log 10 by 4, log 10 by 4. Okay. So I can say log 10 minus log 4. So log 4 I can say 2 log 2 right now, and in the denominator log 10 means it is 1. Okay. So I hope all the steps are clear. Okay. Yeah. So now log 10 is 1, log 10 is 1 minus log 2 is mentioned as 0.3, 0.3 into 2, 0.6 you can take here. Okay. So this is 540 by T90. So I can write here into T90. Yeah. So T90 is how much now? T90% is equals to 540 by 1 minus 0.6 is 0.4. So 0 here. So 4 ones are 4, and next here 2 are remaining. So 1 is remaining. So 12s 3s are okay, and the next how much it is? 2 is remaining. So 5 0. So what is the answer? 1350 will be 1350 seconds will be your answer. So what is the answer for this? So you should fill here as 1350 as your answer. Hope this is clear. Very clear now. Right. Okay. Next few more questions has to be done. Okay. So I will be giving this as your homework. See, this question I have explained in the last class. Just give a try. If not, I will explain in the upcoming session. I mean, already I explained in the last session. Just look at this question. So try, if you are new to this channel, just give a try for this. If unable to do, you can watch the previous videos. I mean, previous session on chemical kinetics. Okay, then next. Yeah. So what about this? So A is forming some product, is a first order reaction. The time required for decomposition of A to half of its initial concentration is 60 minutes. It means T half is given. The rate constant of the reaction is very easy now. So how do you calculate this? See, first order reaction time required for decomposition of A2, it's half of the reaction. So what is the formula I have given? T half equals to 0.69 by K. So what they are asking? The rate constant K they are asking. So K equals to 0.69 by T half. So what is the T half they mentioned? So T half mentioned as 60. So substitute there, you will get one of these options. Okay, right. Okay, give a try for this and mention answer in the chat box. Yeah. So what about this question? Look at this, very theoretical, very easy and theoretical question. The first order, the rate of the reaction for this given reaction. See, the rate of the reaction, okay, for the given reaction is, the rate is given like this, rate equals to K1 into concentration of reactant. Only one reactant they have taken, only substrate here we have is RCl, base is not considered. It means rate of reaction depending only on concentration of alkyl chloride concentration only. Okay, then the rate of reaction is, what happens to rate of reaction? See what they are saying, statement 1, the rate of reaction doubles on doubling the concentration of NaOH. See, rate is directly depending on what? concentration of alkyl chloride only. Here there is no term, means it is 1 here right now, and there is no concentration of NaOH term in the rate law expression, this rate law equation. Therefore, it is independent of concentration of NaOH. Right now it doesn't depends upon concentration of NaOH, okay, as per the equation. And half, rate of reaction will be half on reducing concentration of RCl to half. Yes, this is somehow looking correct only. Let us verify other options also. Decreased on increasing the temperature of the reaction. You tell me, rate of reaction will be enhanced by increasing the temperature, not by decreasing the temperature, okay. So this is incorrect. See, they are saying on increasing temperature what happens, rate of reaction increases, they are saying decreasing, so remove it. So unaffected by unaffected by increase in temperature of the reaction. See, we cannot decide this effect of temperature directly here. Generally increases with increase in temperature for exothermic reaction and decreases by decrease in temperature. I mean, if temperature increased for an exothermic reaction, rate also increases, like that you can say, okay. So here we will study those things in Arrhenius equation, okay. So these are incorrect. Like what is the exactly correct one here for this? The reaction rate of reaction will be half if concentration is also halved. If concentration of RCl, see, R is directly proportional to, rate is directly proportional to concentration of alkyl chloride. If concentration increased, rate also increases. Since power is 1, if it is increased 2 times, this is also increases 2 times. If it is decreased by half, this is also decreases by half. Therefore, suitable answer for this question is option number 2, right? Right, yeah. Next, look at this. The rate constant for first order reaction is this much, okay. The time required to reduce 2 grams of reactant to 0.2 grams. Very easy again. See, they are saying rate constant is given, they are asking time required, T is asking. So 1 by K into 2.303 log concentration of initial concentration of reactant A by A minus X, okay. So T equals to 2.303 by K. What is the K given? So 4.6 into 10 power minus 3, okay. 2.303 by 4.606 into 10 power minus 3, okay, right. Log, what is the initial concentration mentioned? 2 grams. So take 2 grams, okay, and 2 grams is converted into what is the remaining concentration of reactant? It is 0.2 mentioned right now. So hope this is clear how I am taking 2 by 0.2, yeah. So this I can write, remove this decimal and write 20. So this is 10 times, yeah. Again this will be how many times? 2 times here. So you have time as 10 power minus 3, I can write 1000 in the numerator by 2 log 10, that is log 10 is 1. So this is 1 into, so this will be 500, okay. So they are saying time will be how many seconds? 500 seconds. So very easy now, this is NEET 2020 question. Very simple questions from this chemical kinetics. Just focus on the topics that are included in your PYQs especially, okay, as per the syllabus. Stick to the syllabus and just look at the PYQs. Once after learning all the concepts of chemical kinetics, just focus on each and every model of the question in the PYQ books, okay. That will really help you. Hope everything is clear, yeah. So if any doubts are there, just write in the chat box, yeah. If no doubts, just look at this. Few more questions I am showing here. See, just look at this. This is about zero order reaction. See, in the last session I have discussed this. If not able to solve this question, you can watch that video, okay. So this one is MCET question, and again you can look at this molecularity order. This is also discussed in the last session. Now I am projecting just for make you feel clear with this concept. If you are unable to answer, just watch the previous sessions, Okay, so this is about first order like reaction, first order reactions and half life of the first order reaction and T75% of the first order reaction. I hope you got how can you calculate if they ask Tx% by Ty% of this reaction based on the understanding of the topic. Okay, now in the next sessions I will be discussing second order and nth orders, followed by the other topics like what are the factors affecting, and also factors affecting like temperature, that is explained by Arrhenius rate equation, like equation. Now we will discuss all those things. So just stay connected with this NEET World YouTube channel. Yes, thank you for watching.